Hello and welcome to my data structures assignment program. So essentially, I'm gonna go through a walkthrough of this program. First, what the program does. So the program is essentially an ATM banking solution for businesses, and it makes a perfect use of classes, objects, inheritance, and abstract classes. And essentially, what the program does is it provides a like ATM backend, for example. So in this scenario for my program, it would be someone like approaching an ATM machine, and then all of the backend operations would be within this program. So the main.py folder has about like almost 300 lines of code, but the code is mainly just for like formatting purposes, but most of the actual functionality is within the classes. And this program, what makes this program really cool is that it's fully fledged with a JSON database, so that it's not like a temporary file. So once you make changes or create like a new user, it updates it to the database.json file forever, and it'll always load it when you run the program. So it's like a real database that works, and it exports it in the JSON format, which is the industry standard for like moving around data, so that if a bank were to actually use this, they can quickly just port over the database.json file into whatever systems they want. So it just makes it really adaptable. And I'm pretty sure even the like Federal Reserve of Canada outputs their information in JSON. So yeah. So I'm quickly just going to go over the core user flow of the program. So there's two ways. It's either you log in or you create a new account, and then after that I will then go into detail, and so that once you see how the program works, I'll then go into how objects, the UML diagram, and all that helped create and optimize this program. So if I just hop over to our database.json file, we can see that I preloaded a couple accounts here. So we have my account, another account, and another account. So we're just first gonna try and access our account. So we're just gonna run this. So this would be like someone heading over towards an ATM machine. And let's say, okay, I want to log in here. So I'll just type 1 to log in, follow this. Okay, my username. So for the purpose of this, let's just say I want to access this account here. So I'm just going to type the username, which is Alex123, and I could also implement a password function, and it would be the exact same thing except with an additional layer, but just for the purposes of demonstration, it's just quicker with the username. But the password would be the same thing, just an additional thing. So checks, okay, my username exists, and over here we can see that it first shows an account overview of the total account balance. So that would be my checkings account, savings account, and then minus the amount of debt, so the credit account. And that says, which account would you like to access? So here's when I can make changes. So I could either type 1 for checking, type 2 for savings, type 3 for credit, exit, or if I just type my username exactly, I can actually update like the account information. So let's just say quickly I want to change my data a bit, because maybe it's a different person now. So I'm just gonna type in my username, and here I'm just gonna put my new name here. I didn't put my last name last time, so this time I'm gonna make sure I put in my last name so that everything works. Email, let's just say 123@gmail.com. And if I want a username, let's just try something like Alex12345 this time, because we didn't have enough security. So if I do that, we can see here that the account overview is now updated with our brand new information that we chose. And yeah, so now let's say for example, if I want to go into the checking, and in the checking I can then choose a variety of options here. I can either deposit money, withdraw money, just take a rough look at my account. So if I just do that, I just press type 3, it just prints out the account overview again to just, if I would just want to keep tabs on that while I'm in the checking directory. So let's just head back into my checkings account, and we can see here in my checkings account that I have $8,900, so that's pretty good. So for the purpose of this, let's just say I need to buy something, and let's make a withdrawal here. So I'm just gonna withdraw like $1,500, and we can see here that the new balance would be $7,499.49. So you're wondering, where did this 25 cents go? And that's where the transaction fee would come in, and I'll go into detail, or actually I'll just go into it right now. So here from an administration side, first, when everything is initialized, the admins of the bank would be able to just hop into the code and simply change either the interest rate, the bank withdrawal fee, or the bank transaction fee, and it would all affect how users interact with the machine. And in the future, I think if I had a bit more time, we'd probably also add an additional interface for an admin login, but just for the purpose of time, I just couldn't implement this thing. So here we just made a withdrawal. So let's say I also need to borrow a little bit more money, or actually I want to pay down some loans today because I just got my paycheck. So you can see here that I currently owe about $3,000. So I can just make a deposit type 1, and I got my paycheck of $1,200 today, and boom, just like that, my new debt balance is $1,800, and you can see here that my account balance has actually gone up because I just reduced the debt, total debt. So let's say we're just gonna wrap it up today, and if we remember, looking at it right now, obviously the money does not match up. You can see here that the balance for the loan account is $1,800, and nothing has changed yet, and it's only gonna update when I exit out of the program. So everything is stored locally until I finish with my program. So let's say I'm done with today. I don't want to do anything else. I just type 4, and boom, it says thank you for banking with Alex. And we can see here on the left here that my program automatically updated the JSON database with a proper JSON format, and it properly chose the right user and updated everything. So it was just as we said before. You can see here this was our previous information, this is the new information. So now the name is Alex Liu, the username is alex12345 instead of alex123, and the email is 123@gmail.com instead of my PDSP. Okay, so for the purposes of time for this demonstration, I'm just gonna create an account, but I won't just do any actions. You can play around with all of the possible actions you can do on the ATM, but I'm just going to create an account to show that we can also append dictionaries to this JSON database, or append users. So I'm just going to restart my program here. Okay, so this time I want to sign something up. Oh, hold on. There we go. Sorry, I think I must have clicked run too many times. So if I just do sign up here, and let's say my name is Joe, my email is wow123@gmail.com, and let's just say username is testing123. So here we can see the account overview, and obviously as a new user we have $0, and here you can just deposit money, etc. And then for the purpose of this, let's just quickly exit. And we can see here automatically on the database, it just appended this brand new user with absolutely no data. And if we just want to check here, if I head back in, so let's say I just went over to the ATM, I created the account, and I had my lunch break, I'm back now. I can now log in to this new account that I just created. So if I just type in the username, testing123, boom, which account would you like to access? Let's just say now we finally got our checking. Let's make a deposit. Let's make a deposit $500. Exit, and we can see here that now this is again changing the value of this username with a brand new total and brand new checking. minus of course the amazing bank transaction fees, which can be changed from an administration standpoint. And yeah, that pretty much wraps up the like just main core user flow. There's a bunch of other functions, but they're like similar in nature, I'd say. So yeah, that pretty much wraps up the walkthrough. So now I'll go into the specific details for how everything helped. Okay, so for how the UML diagram helped me plan my program was that it really helped me kind of look at things from a macro scale instead of just the code, because like when I'm working in the code, like I can only focus on that one function or that one class, and it's hard, you know, sometimes to be either like wasting too much time creating this really like advanced and get lost and create this really advanced function or class. Whereas here, if I look at it from like a more macro scale, I can see how my entire program would be formatted and planned accordingly, so that it's first of all within the expectations of the assignment and what I want for specifically for the program, and keep it manageable so that I'm not like, you know, if I'm just here at my coding thing, I'm not adding like 40 different features and then realizing, oh, I have to do that like 4 more times, right? So in that aspect, that's what this detailed UML diagram really helped me with, and it also really helped me maintain consistency between my variable names and how all the classes are set up and the specific structure. So like the composition here, I made sure to and remembered to set that up, as well as the inheritance for and abstract classes for checking, savings, and the credit line. In terms of the use case diagram, the use case diagram again really helped me envision so once the main classes were complete, how the user interface, so to speak, works, and how everything, how a user would go down and interact with these classes and the entire program as a whole. So the use case diagram really helped with that, in the sense that I know one by one what do I want to do. So I need to first format the create account or check account details, edit account details, and one by one, based on the use case, I then format the user interface based on that, as well as the functions of the bank admin. So objects were definitely a key part and used extensively in the program. So how an object works is essentially it is a variable with a variety of attributes and like functions that you can call on it. So like the best way I would describe an object is like and like the class relationship is, I would think of like a class as like the blueprints of creating this object. So for example, it would be like the blueprints of a house, and then but then the actual house is then the object, and then a house has many features, right? Like amenities and things like that, and max capacity and things like that. So, and then based on the house that you created, you can then use the features of within the blueprint of, let's say, how many people it can hold. So objects were used really extensively in this program and played like a key role in maintaining all of the core accounts, which would be the checking, savings, and credit account. Oh, and accounts object. So basically, for example, if someone logs in and they choose to log in, basically here we have the user checking object here, and this essentially is the checking object class, which stores all of the information such as the balance of the checking account and just other information like the transaction fee and all that. And we can see the same thing here, the user savings object, and this object would then be for the savings account, which then controls and interacts with their balance on their savings account. And then we also have the user credit object, which same thing, maintains and keeps track of the current user credits like amount and performs functions. And then also there's the user info, and this again is where the general information is stored and manipulated. So these are like the 4 key features of the program, and the 4 key features of the program all use an object. And obviously I think objects were really necessary for this particular program, because if we see here, The program, and this is basically just interface alone, is about 300 lines of code. And because the many of the functions, such as making withdrawals, making deposits, and making transfers and all that, are called repeatedly throughout the program. Like off the top of my head, maybe like 10 times, or 10 to 15 times in total. And if I was to write the specific functions or store the data, I would have probably like 20 to like 30 variables I have to keep track of, as well as 10 to 15 separate functions. And you can imagine how complex this program can be. So what the objects really allowed me to do was compartmentalize, or make compartments of the core features of the program, such as the action of withdrawals, the action of transfers, and that really simplified the process and makes it the code for the main interface much more usable and readable. So for the extending objects concepts, I used two of the possible concepts in Python. So there's no interfaces in Python. So first are abstract classes, and this can be seen with the balance class here. So we can see here we go from ABC, import ABC, which is abstract method. My use of the abstract method is it makes it so that for each subclass you must have a deposit and withdrawal function, because that's like the basic operations of a bank. So that as you scale up and create new account classes, this essentially just makes it so that it reduces the amount of possible error, and it makes sure that you have the main like must have, regardless of what kind of account you have, features, which would be deposit and withdrawal. So using inheritance essentially allows me to ensure that each additional subclass has all of the main core important features, which would be making a deposit, making a withdrawal, and checking the balance. And then also saved on the amount of additional functions, because again, I would just be repeating myself if I just made if I just kept making check balance functions. So if we head back to our main.py, we can see here that file reading/writing was used for our JSON database here, and this is like a very important feature, because without reading from this bank database and then updating the values after user is done, we would only be able to store all of the actions in the temp memory. I'm not sure if there is a way to otherwise keep that, like, your changes permanent, which kind of defeats like the purpose of an ATM banking solution. If you can create an account and all that, but the second when you leave the program, everything gets wiped. So essentially what this does is it allows me to create a really real and something that would be up to standard of a grade 12 uni course, where it does append to a real database and it operates like a real ATM system, where everything is updated and sent to an JSON file, which is industry standard. So in terms of how this task was made easier by file reading/writing, it wasn't I wouldn't say made easier, so to speak, but more so just made possible, that we can actually edit the user and then save that, so that the next time when they hop on the program, they can access the information that they changed. And in addition, it also helped with the compartmentalization of just the program in general, because again, it's all about scalability for something like an ATM machine app. So for example, right now our user sample is quite small, but let's say I had like 200 users or something. If I didn't have a separate database like you can imagine if it was just a plain dictionary, it would take up literally the entire page, like hundreds of lines of code in the main.py. Okay, so when working with an industry standard JSON file, there is a lot of data type conversion that happens. So you can see here with importing the JSON module, we are already first turning this JSON file and translating this JSON type into a Python dictionary. In order to perform like the basic operations of depositing and withdrawing, obviously we can't work in strings, so everything essentially is stored as a float in terms of the numbers. But of course there's going to be cases when we want to output something for the console so that the user can see here it's new balance, right, or something like that, or in a concatenated format. So in those cases, that's when we wrap the string function around. Right here we can see the rounded balance, and in that case it'll output the balance as a string, which then helps and is used in our formatting of our totals and our just new balances here. So that's used quite a lot throughout the throughout each bank account. And then finally in the end, so all of this is currently just stored in the temp class right now. So all of the data, again, the user while they're in the loop is just temporary. But if we go here, we can see that when we want to finally update the account data on the actual JSON file, what we can do here is we turn some of the check balances, which were strings originally, so that we can print it out. We have to change the strings back into a floating point so that the JSON is then saved as a proper number instead of a string. So yeah, that pretty much wraps up my program. Feel free to hop on and just explore and see how the entire ATM system works. It is fully comprehensive. The only thing is there are some errors I didn't have time to fully catch, but like the main ones, like if you don't type a number for this, for like the actual like interfacing, then it won't let you break the program.